Let's do this example. Use the Gram-Schmidt process to find an orthonormal basis for the span of these three vectors. These three vectors are in R3, so they are, if they're linearly independent, they would essentially span all of R3. And let's just say geometrically by inspection, we can see that they are not collinear, not coplanar, so they are linearly independent, and therefore they must span all of R3. So let's take our first step. And our first step is to really just take our first vector v1 and make it into a unit vector. So we need the magnitude of v1, and that is the square root of 1 squared plus 2 squared plus 2 squared. So that's a square root of 9, which is equal to 3. And so we take our vector v and make it into a unit vector. And so we'll divide each one by 3. And then we have our first unit vector. u1 is equal to negative 1 over 3, 2 over 3, negative 2 over 3. Okay, let's look at that geometrically. We have our first vector that we found, and that is going in the same direction as v1, except it's of unit length. And so that's our first vector. Now let's go to step 2. Step 2 is our first projection. We're going to project v2 onto u1. Now, one key, because this is a unit vector, so we can do the dot product here. But let's do the projection. So according to the formula, it's going to be the dot product of u1 and v1, or v2, and then we're going to multiply that by the unit vector u1. So the dot product of u1 and v1, so let's dot these two. That's going to be negative 1 and positive 1, so that's 1/3. And this is going to be 0. And then the last one is going to be positive 2/3. And what we have here is, we're going to multiply this by u1. So that's negative 1/3, 2/3, negative 2/3. So this is just going to be 1. So that's just equal to the same thing. Okay, now we need to subtract to get our actual orthogonal vector. So the orth of v2 onto v1 is going to be v2 minus the vector that we just found. Projection of v2 onto v1, or u1. So v2 was minus 1, 0, minus 1. We're going to subtract minus 1/3, 2/3, minus 2/3. So this is negative plus plus, so that's a minus 1 plus 1/3. That's going to be negative 2/3. 0 minus 2/3, and negative 1 minus negative, so that's going to be negative 1/3. And this is what we would call our W2, and then we would just find the magnitude of that to make sure that it's going to be a unit vector. So W2 is square root of negative 2/3 squared, so the positive 2/3 squared and 1/3 squared. So the denominator is going to be square root of 9, and then we have 2 squared, that's 4, plus 4 plus 1, square root of 9. So that's already a unit vector. So we have our second unit vector. U2 is going to be minus 2/3 minus 2/3 minus 1/3. We have 2 down. And let's take a quick look at how that might look like. So it might be better if we get rid of the axes here, since the axes are going to be not important for us. So we have these 3 vectors. We have the first vector in red here. That's going to be the first unit vector that we found. And now the second vector that we just found, if we get it at the right angle, we see that these two are actually perpendicular to each other. Not only that, but these 2 vectors, the 2 red vectors, are the 2 new unit vectors, and then the v1 and v2, they all lie in the same plane. So I drew this plane already. Again, we get it at the right angle, we can see that those 4 vectors are all in the same plane. Okay, so they're all in the same plane, and now we're up to the third vector, and we're going to project that vector onto the plane and find our perpendicular. And since we only have 3 vectors here, this is going to be our last step, step 3. So we want to find the projection of the third vector, v3, onto now the span of u1 and u2. We want to project it onto that plane. And according to the formula, this is u1 v3, the inner product of u1 and v3 times u1 plus the inner product of u2 and v3 times u2. Alright, so now we want to take the dot product of these things with v3. This is v3. So the dot product will give us, or the inner product will give us positive 2/3 plus 2/3, and this becomes another plus 2/3. And we're going to multiply that with u1, negative 1/3, 2/3, negative 2/3. And now we'll do the same with u2 and v3. So that's negative, negative, positive. 2 times 2 is 4, so that's 4/3 positive minus 2/3. And negative 1 times negative 1 is positive 1 plus 1/3. And then we're going to multiply that with u2, which is negative 2/3, negative 2/3, negative 1/3. So what do we have here? We have 2, 4, 6, 6/3, so that's just 2 multiplied by this vector. And then now we have 4 minus 2 is 2. 2 plus 1 is 3, so that's just 1/3, or 3/3, which is 1. So we just have minus 2/3, minus 2/3, negative 1/3. So we have negative 2 plus negative 2, that's negative 4. That's 4 minus 2. Positive 4 minus 2 is 2. And then negative 4 minus negative 4 thirds minus 1 third is negative 5 thirds. All right, now that we have that, we will take a look at the orth, the actual perpendicular. And that is our vector v3, which was minus 2, 1, negative 1, minus 2, 1, negative 1, and we're going to subtract what we just found, minus 4 thirds, 2 thirds, and negative 5 thirds. So what do we have? Negative, negative, so this is positive 4 thirds, 6 thirds, plus 4 thirds, 6 is bigger, so it's negative 2 thirds. We have 1 minus 2 thirds, so that's going to be positive 1 third. And 1 plus negative 1 plus 5 thirds, so 5 minus 3 is 2, positive 2 thirds. And you can check that if we call this W3, that the magnitude of W3 is actually also equal to 1. So we don't need to normalize it, it's already normal. Then U3, the third unit vector, is negative 2 thirds, positive 1 third, positive 2 thirds. Okay, so let's take a look at that. So now we're looking at this projection of, let's take away the other vectors right now, the first two, v1 and v2. So now we have u1 and u2 vectors that span a plane, they're perpendicular, and then we have a third vector that's not on the plane. We're going to look at the projection vector, and then after you project it, you do the subtraction, and then you get this third vector here that's perpendicular to the plane. And so let's get rid of that and get rid of the plane. You'll see now you have an orthonormal basis. They're all mutually orthogonal and they all have unit length. And so that completes our problem. We have our complete set of vectors. So orthonormal basis is going to be given by our u1, which is minus 1 third, 2 thirds, negative 2 thirds, minus 1 third, 2 thirds, negative 2 thirds. Our u2, negative 2 thirds, negative 2 thirds, negative 1 third. And then our u3, negative 2 thirds, 1 third, 2 thirds. Okay, that's it.